Hello, I'm Dr. Christopher Sabine, Professor of Oceanography at the University of Hawaii, and today we're going to talk about how to do an alkalinity titration. There are 5 basic steps to the titration: cleaning and preparing the cell, preparing the sample, the initial acid addition and degassing of the sample. Then we've got the titration, and the last step would be doing the calculations to calculate the alkalinity. So first thing we want to do is to raise up the burette away from the sample and the pH electrode. So we raise those up. Then we will remove the sample. You've got the stir bar in there, so you want to retrieve that. Rinse off the stir bar with your distilled water. And just set it aside until you're ready to use it again. You can dump the old sample in your waste container. Remember that the samples that you're titrating have mercury in them, so you want to save all of your waste so that you can put it into a proper mercury disposal site. We rinse the cell 3 times with your distilled water. And then completely dry the sample, dry the container. So remember, the alkalinity is a function of the volume of the sample that you're titrating. So if you have any water in the titration cell, that adds to the sample volume, and you're not accounting for that. So you want the titration cell to be completely dry when you start. And next we want to fill our burette. So we just did a titration before, so I have to refill this burette back up to the starting point. Now you're using 0.1 normal acid, hydrochloric acid, for the titration that has 0.6 molar sodium chloride in it. And I want to set it so that the 0 is right on the vertical line of the calibrated burette there. Wipe down the outside and then put it back into your holder, making sure that the calibrated portion is facing towards you. Okay, now we're ready to load our sample. So you take your sample bottle, open it up. We're going to use a 50 ml pipette to process the sample. But first you want to, anytime you're using a new sample, you want to rinse your pipette so you don't have any previous sample in there. Okay, so now I've done my 3 rinses. Now I'm going to fill. You want the bottom of that dip to be right at the line when you bring it up. That's how you know you've got exactly 50 milliliters. Okay? Then we add it to our titration cell. When you're done, there's still a little bit of water right in the tip. That's supposed to be there. So it's calibrated assuming that that sample is there. So now we've added our sample, cap that and set it aside. Now you can turn your stir bar on. You want it to turn it on so it's just fast enough to create this little dip in the surface water. Okay, now we're going to put our electrode in. You don't rinse the electrode because the electrode doesn't like to be exposed to different salinity waters. So we don't ever rinse it with the DI water. You just pat it dry so that gets any of the previous sample off. So there's 2 parts to this electrode. You see this sleeve here, that's the second part of the electrode, so that needs to be just in the water, but not so deep that the electrode is being hit by the stir bar. Okay, and you want the stir bar to be going fast enough to just create a little dimple in the surface of the water. Now we're going to add the burette. You want just the very tip of the burette to be in the water. Okay, so now the sample's prepared. We're ready to move on to step 3. Your readings on your voltmeter should be in the negative values. That means it's a basic solution. So typical seawater is a pH of around 8, which is on the basic side. So you should be getting negative readings when you first put it in. Okay, now what we're going to do is we're going to add a shot of acid to bring the pH down to the point where we want to start the titration. Quickly add the 1 milliliter because there's a obvious mark there, so you can just quickly go up to there. And then I go around once more. That's 1.1. One more time. 1.2. And then I go to the 5. So that's 1.25 milliliters of acid that I've added. Again, you want to make sure that the point that you're comparing is lined up exactly with the vertical line there. So now we're going to turn the stir bar up, and then we're going to let it run for 10 minutes. Had our 10-minute break while the sample has been degassing. We can turn the stir rate back down a little bit. Again, you want just a little dip in the surface. And now we start doing the actual titration. I have these alkalinity sheets that allow me to keep a record of everything that I've done. So our first bit of acid is 1.25, and I'm going to record the voltage reading. So it's 0.19413. And then what we're going to do is we're going to do titrations in increments of 5 microliters. So that's on this scale is just moving from 5. Now 5 to 0 and 0 back to 5. You can use whatever increments you want, but I find that a nice convenient way so I don't have to think too carefully about where I am and what I'm doing. So I'm at 5, so I'm going to go just turn this clockwise to 0. And then write down the value. And then I go back to 5. Write down the value. Now we've completed our titration, and we can enter these values into the computer to calculate what the alkalinity is. But one last thing before we do that, the last part of all this is you want to read the temperature. So I use this fluke meter, stick the probe in, and record the temperature, 21.5 degrees Celsius. I also need to record on here the date and time. All right, so now when we move to the program, you want to make sure you're on the GRAN page. There's 2 pages. There's a GRAN page and a nonlinear least squares page. So make sure you're always typing on the GRAN page, and it'll get copied over to the nonlinear side. So next to each volume, you want to enter your millivolts that you recorded. So it's want to make sure you enter the temperature. And the salinity. Then you have your preliminary alkalinity estimate here, so it's 2276. Then we go over to the nonlinear page. All the information from the previous page is copied over, but we want to do the calculation. So you go to your Excel function called solver, and you click on that, tell it to solve, OK, and then it gives us our alkalinity value of 2347.6. So the difference is the grand calculation does a linearized function to estimate alkalinity just based on assuming that there's only carbon in the water. But in reality, seawater has many other compounds, so the nonlinear fit accounts for all those other, and you see the difference. The grand calculation came out with 2259, the nonlinear came out with 2255.8. The difference between those two are the alkalinity that was contributed from those other species. So that's our final number, and now you've done a successful alkalinity titration, and we're done, ready to move on to the next sample. Thank you.